Hello, guys. Welcome to another episode of Cuda Education. So, today we are just adding some files to our project. So, we are continuing our path of building up to the modern renderer project, which is part of the Apple sample code library. And, we're starting from a fresh Xcode project and building up to the final product. So, we are in the midst of things. For this episode, we're simply adding files to our project. Math-related files, camera-related files, and I guess what? Shader types. Is that what you would call it? So pretty much this is the AAPL math utilities file, which was added. This is the standalone math library with float 1632 conversion, degree radian conversion, fast random number generator, vector lerp, 3x3 and 4x4 matrix construction, rotation, scale, translation, look at matrices, left, right hand, orthographic and perspective projections, full quaternion library, and uses attribute overloadable for C function overloading with SIMD types, right? So this is the math AAPL math utilities header file, header for vector matrix and quaternion math utility functions useful for 3D graphics rendering. Okay, so we're just adding files today. Nothing special. These files would come in handy later on, but for this particular episode, we're just looking at what's inside of these files. So this is the header file, and we can see a lot is going on here. Okay, but we're not going to press the issue too much here. We're just looking and seeing what is what and what's going on. Okay, so that is math utilities APL math utilities header file. Now there's also the main file, which is this implementation of vector matrix and quaternion math utility functions useful for 3D graphics rendering with Meadow. Meadow uses column major matrices and column vector inputs. So again, guys, we're not pressing the issue right now. Right now we're just looking at what's going on and keep it moving. All right, so a lot of capability here, math related stuff, of course, and that is that. Let us get to the next file, APL shader types header file. So let's go to header for types shared between Metal shader code and Objective-C source. Shared header for CPU and GPU code containing AAPL buffer index, enum, buffer binding slots, AAPL vertex attribute enum, position normal tangent text chord, and APL camera params struct, 6 matrices, 6 frustum planes, inverse projection Z values. Okay, so again, we are just looking at these files and see if anything catches your eye. Okay, so that's the APL shader types file. And then we have the APL camera. It's a header file and the main file. Okay, let's just go to that. So let's go to the header file first. Abstract. Header for class representing a 3D camera and data directly derived from it. So let's see what the man has to say. So Objective-C++ camera class with perspective and parallel orthographic projection modes. Lazy dirty flag pattern. Matrices only recompute when properties change. View matrix via lookat, projection matrix, and all derived matrices inverses. Frustum plane extraction from the transposed view projection matrix. World space frustum, corner computation, rotation, face point, face direction helpers. So yeah, let's just look at the header file and then the main file. So we have, so a camera object used for rendering standard perspective or parallel setups. The camera object has 6 writable properties: position, direction, up, define the orientation and position of the camera near plane and far plane, define the projection planes. View angle defines the view angle in radians. All of the properties are generated from these values. In addition, the renderer populates the APL camera param struct lazily to reduce CPU overhead. In my AA in my Apple Metal videos, I have messed around with the near plane and far plane, so I definitely know about that. And basically, what happens is that if you shrink the near plane and far plane, which is like the distance how far out the camera sees, you will basically see either at the top of the screen or the bottom of the screen where the pixels are just blanked out, right? And it has to do with the near frame and far plane setting that you have, right? But let us just go through, the different things happening in this file. So we could see distance to the near plane to the position in world space, far plane, distance to the far plane to the position in world space, right? Direction, position, all of that stuff, right? So we're not too worried about all this right now. We just want to have an idea of what's going on. So this is the header file, and then this is the main file. Implementation of class representing a 3D camera and directly derived from the... So of course, guys, we will get into all this stuff at a later point for sure. We'll start tinkering with the values and see how it affects our application, right? Right. So as far as we're concerned, the app hasn't changed. We still have our dark blue background, navy blue background, dark blue background with a window. So I mean, I'm not going to run it because it's basically the same thing as we had before. But computer graphics, a lot of stuff was going on. Don't expect to know everything in one episode or sitting. It is a long-term process, but we will go down that path and learn as we go. So this is it, guys. This is Cuda Education. Thank you for watching. You know what to do to help the channel. Tell your friends if you know anyone that's interested in computer graphics. Definitely tell them about this channel and all that we're doing. Maybe work on the stuff together, tinker with the stuff together. We will continue on our path. But again, all we did here was just add files to our project. We haven't even referenced anything in the main files that we had before. We've simply just added the files. So we added the camera files, the math utility files, the shader types header, APL shader types header file, and that's it. So 2, 2, and 1. So 2 header and main file, 2 header and main file, and then the APL shader types file. And that's it. Thank you for watching. Have a great day.